Okay, good morning. Welcome to
FamilyMath412a.
412. So FamilyMath412. Today we're going to talk about a problem I heard an MIT math professor named Bjorn Poonen talking about last week when I was at MIT. I was actually just sitting in a lounge, working, reading, and he came in and went on one of the chalkboards and was talking about this problem with the students. So it was actually pretty neat to just hear the problem, and I didn't even realize how cool the problem was until yesterday when I was sort of thinking about it again. So here's how the problem starts. Take a square whose side length is 2.
Yep.
And you divide it into 4 equal smaller squares. What are the side lengths of those squares?
1.
Okay. And then you put circles inside of those squares. Inscribed circles. What's the radius of those circles?
The radius
Of these big circles.
is going to be 1/2.
That's right. Good job. And then you draw this small circle here that touches all 4 circles and has its center as the center of the square. Okay, do you see that circle?
Mm-hmm. It's right in there.
So, first thing we want to do is figure out what's the radius of this circle. How would we do that, do you think?
Well, we can make, if we draw the other radius in here of this circle,
Okay.
we have this square that says side length 1/2.
Yep.
And we could draw the smaller square in here maybe,
Okay.
with this radius.
Yeah, but unfortunately we don't know that radius.
Yeah. But we do know where it touches the circle.
Oh yeah,
I
where?
think.
Where is that?
So we just look at this quarter circle,
Uh-huh.
it touches at the middle of this arc.
Okay, why do you think that?
Because there's 4 of them, there's 4 circles. This is all very symmetrical.
Yeah, it is very symmetrical.
And this is the center of the circle is the center of the square.
Okay.
So,
So this point here where it touches is probably the middle of that arc. It's good. Good thinking.
that might help us, I'm not sure. Well, I now have an idea as to how we can find it.
Okay.
We can look at the diagonal
All right.
of
You
this, which is,
want me to draw the diagonal?
yeah,
Okay. The whole thing.
the whole diagonal.
All right. Let's draw that whole diagonal.
Wouldn't this be 2 times the square root of 2?
Very good. Why is that whole
Well,
diagonal?
Because the Pythagorean theorem, if you know these two, so Pythagorean theorem is
2.
a squared plus b squared is c squared. So 1 squared plus 1 squared is 2.
Uh-huh.
And then this side length is the square root of 2, and there's 2 of them.
Very good. Hey, high five. Good reasoning. Okay. Now that we have this diagonal drawn in, what do you want to do?
So from here, this distance from the edge of the circle to this point is the same distance from here to here.
Oh, why is that?
Because this is a straight line,
Uh-huh.
and this is a square.
Okay. So it's sort of another symmetry
Yeah.
argument. That this distance and this distance are the same.
So we have this length is 1,
Uh-huh.
and this length is 1.
Right?
So we have 2 plus 4 times the radius is 2 root 2.
2 plus 4r, sorry, I'm out of room, equals 2 root 2. Very good.
Then 4r is 2 root 2 minus 2.
All right, I'm going to give myself a little bit more room. 4r equals 2 root 2 minus 2.
R is, it'll be root 2 minus 1 over 2.
Very nice. Now, do you see that last step? We divided by 4, so it looked like we might have a 4 on the bottom. But why did we not have a 4 on the
Because
bottom?
we have these two.
We have some 2's on the top
Yeah.
that cancel with the 4. So you get square root of 2 minus 1 over 2. Very good. So we found the radius of this circle, this small circle on the inside. Okay?
Yep.
Mm-hmm.
All right. Awesome. All right, let's move on to the next problem.
Okay.
Alright.